Hi everyone, I'm Laura, and welcome back to the channel. Today we're diving into one of the most powerful ways to confirm or break through your family tree. Combining traditional genealogy research with DNA evidence. You've probably collected birth, marriage, or census records, and maybe even done a DNA test. But how do you make both types of evidence work together to actually prove a relationship? That's exactly what I'll show you today, step by step. We'll cover how to form a question, test it with documents, check it against DNA, and then pull everything together into one clear proof. Before we jump into the steps, let's understand why this combination matters. Traditional research gives you names, dates, and places, the who, when, and where. DNA adds biological proof, the how you're actually connected. When used together, you can confirm family links that paper records alone might leave uncertain, like verifying a parent-child relationship when no birth record exists, or sorting out multiple men with the same name in one town. Paper tells the story. DNA confirms the connection. When you overlap both, that's when your research moves from "I think" to "I can prove." The very first step is to create a specific research question. Don't start with, "I want to learn about my Smith family." That's too broad. Instead, ask something like, was William Smith, who lived in Ohio in 1880, the father of my great-grandmother Jane Smith? That's focused. It names a person, a relationship, and a time frame. Then, write a hypothesis, a statement you're testing. Based on census and local records, I believe William Smith is Jane's father. You'll now gather documents and DNA evidence to support or disprove that claim. Next, dive into the documentary research. Pull every relevant record you can find about the people in your question. Start with the basics: birth, baptism, or christening records, marriage and death certificates, census or local household lists, wills, land deeds, and probate files, newspaper mentions or obituaries. Create a timeline of everything you find. If possible, record each piece in a spreadsheet. Year, record type, who's named, and what it says. Now, ask, does the evidence consistently point to the same family? Are there gaps, like a missing birth or an unclear relationship? Are there other families with the same surname in the same area who might cause confusion? Let's say you find Jane Smith listed in the 1880 census in William's household as daughter. That's a clue, but not proof. You'll need supporting evidence, maybe her marriage certificate listing his name, or a will that mentions her. We're not proving anything yet. We're just identifying what the paper trail can and can't confirm. Once you've explored the records, now it's time to see what the DNA can tell you. If you or a close relative have taken a DNA test, on Ancestry DNA, MyHeritage, 23andMe, or Family Tree DNA, log into your account and open your match list. Start by identifying known relatives first. Label them in your tree. Then, look for matches who seem to connect to your research question. For example, if we're testing whether William Smith was Jane's father, we'd look for matches who descend from other known children of William Smith. If Jane's descendants and William's confirmed descendants share consistent DNA segments, that's biological evidence supporting the paper trail. We don't rely on one match. We look for clusters, groups of people who all share DNA with each other and descend from the same ancestor. That's where tools like Ancestry's shared matches or MyHeritage's genetic groups help. Now comes the most important part, putting the puzzle together. Create 2 columns on paper or in a document. Label one side, Document Evidence, and the other, DNA Evidence. Under Document Evidence, summarize what you found. Census, Jane listed as William's daughter, suggestive. Marriage record, lists William Smith as father, strong. Will, mentions my daughter Jane, very strong. Under DNA evidence, summarize your findings. Jane's descendants share 120 with known descendants of William's other children. Multiple matches triangulate on the same DNA segment. Now interpret. When both sides point to the same conclusion, that's strong genealogical proof. If they disagree, pause. Sometimes the paper trail is wrong. Adoptions, step-parents, or informal name changes can cause that. Sometimes the DNA matches may be too distant or come from multiple lines. The goal isn't to force a result, it's to find where the evidence overlaps and where it doesn't. Once you've gathered both types of evidence, it's time to write a short summary, what genealogists call a proof statement. Your proof statement should include your research question and hypothesis, what you found in the records, what the DNA supports or contradicts, your conclusion, with a confidence level, for example, supported with strong evidence, or needs additional testing. Here's how you might phrase it in your notes or report. Documentary evidence indicates Jane Smith is the daughter of William Smith of Ohio. DNA evidence supports this, showing 125-140 cm shared segments with descendants of William's other confirmed children. Both lines of evidence agree, meeting the genealogical proof standard. A few quick warnings before you start combining evidence. Don't assume one DNA match proves a relationship. Always confirm with clusters. Be cautious with distant matches under 30 cm. They can be misleading. Check for endogamy or intermarriage in small communities. And always cite your sources, both the document and the DNA kit numbers or links. Remember that DNA is personal data. Always get permission before sharing results or screenshots. If you discover unexpected relationships, take time before contacting people or posting about it. Genealogy should be about truth, but also about compassion. If you found this helpful, hit like and subscribe for more genealogy tutorials every week. Tell me in the comments, what's one relationship you'd love to confirm using DNA? I might feature it in a future walkthrough. Thanks for watching, and happy ancestor hunting.